My name is Joe Maniscalco. I'm the Field Service Manager for Outboard Division, and what we have here is our Helm Master fully integrated boat control system. This is a triple engine application. We have triple 300 horsepower 4.2 liter engines, and as you can see, all the componentry for the Helm Master system is laid out on the transom assembly here. We'll kind of go over each component. Up here you have PCUs, one for each engine. Next we have SCUs, steering control units. On the steering control units, for a twin engine application we would use one. For a triple application we use two. So we bring the third one to this PCU right here. These are steering motors, which provide hydraulic pressure to our steering cylinders. And on our steering cylinders we have sensors, which feed position of each engine into our SCUs. So each engine operates independently of its counterpart. So we're able to control the boat completely by using all three engines independently of each other, whether that be in forward, reverse, and depending upon the steering angle that we request the engine to be at from our helm unit.
So the question, I guess, would be, can they then go totally in different directions and vector thrust forwards and backwards at the same time?
Absolutely. Depending upon what we're asking the engines to do, the engines can steer independently of each other. The third engine would then supply assistance depending upon what it's being requested. So they can move in or out, forward and reverse, independently of each other. So up at the helm, we start with our engine ignition and start panel. So on the triple engine application, I can press one button and all three corresponding engines will turn on. I press one button here, and this is the all start. All three engines will then start in sequence. We have two gauges here for our three engines. Then we have our joystick control and our remote control. On the remote control, we have speed control, which allows the operator to engage into gear, and using the center button at the top of the control box, change engine RPMs 15% up and 10% down. That varies depending upon the engine RPMs. From there we have station control. This system can have an upper station setup where you can switch from the main station to the upper station and likewise back down to the main station. We have a trim assist feature, which when engaged and the throttle is increased at preset RPMs, the engines will trim up automatically on their own. As you continue to go up in RPMs and hit the next stage, the engines will continue to trim for automatic trimming. On the bottom, we have single lever. When engaged, this lever becomes obsolete and does not get used. And everything is controlled from the one lever, all three engines at one time, forward and reverse throughout its full range. We have center engine operation only. When engaged, just the center engine will operate from the control. And then finally we have free throttle, which basically removes the shifting and the engines will operate in free throttle only. So how about we move to the back side and see what's on the back side of this. This area right here was our start panel, and our little warning horns kind of stick out of these little boots right here. Right here is a hub connector, which basically transfers information from our gauges to our HCUs. This is an HCU, which is a helm control unit. Now in a triple engine application we use this second HCU because the remote control houses the primary HCU. So this would be used on a triple engine application where we're running another HCU. These are our gauges, basically a connector here, which go into our hub. That is our helm system, which is fully electronic. Two feeds out of it, which feed into our HCUs. Right there is our joystick control, which a single lead comes out of there and connects into the HCU. And that's the complete system.